The most dangerous thing about the eruption that just happened in the South Pacific is not the 54,000-foot cloud of ash blasted into the stratosphere. It is the fault directly beneath it. The Ambae volcano in Vanuatu erupted yesterday, perched on top of one of the most active megathrusts on Earth. A fault rated for a magnitude 8 earthquake and a tsunami that could cross the entire Pacific. Officials in Japan are already investigating whether a wave could reach them. Stay with me and you will understand exactly what that fault could do. Yesterday morning, a volcano in the middle of the Southwest Pacific threw a column of ash 54,000 feet into the sky. That number is the whole story, so let me put it where you can feel it. 54,000 feet is a little over 16 kilometers straight up. The airliners you fly in cruise somewhere between 35 and 40,000 feet. This ash cloud punched through that entire layer and kept going, topping the world's air traffic system by more than 14,000 feet and driving deep into the stratosphere. That is the altitude band we associate with the most violent class of eruptions on Earth, the subplinian and plinian events, the ones that carry ash across whole ocean basins and shut down airspace over enormous distances. The volcano is called Ambae. You may also see it written as Aoba. It sits in the northern islands of Vanuatu, a chain of islands in the southwest Pacific east of Australia, and in the global catalog of the world's volcanoes, it carries the number 257030. Yesterday, at 40 minutes past 9 in the morning local time, it produced the single largest explosive pulse of an eruption that has been simmering all year. The Wellington Volcanic Ash Advisory Center, which is the aviation authority responsible for warning aircraft in this part of the Pacific, issued a formal advisory measuring the top of that ash cloud at flight level 540. That is aviation shorthand for 54,000 feet. By the time they logged their next observation about an hour later, the cloud had settled slightly to 50,000 feet. It was still one of the tallest ash columns anywhere on the planet this year. The measurement did not come from someone standing on the island guessing. It came from Himawari 9, the Japanese weather satellite parked in geostationary orbit over the western Pacific, watching this region continuously. So the 54,000-foot figure is a satellite-verified, publicly issued number, and I want you to hold on to it, because everything that makes this event frightening flows from how far above the ordinary this single measurement sits. Here is why seasoned volcano watchers sat up when this number crossed the wire. For most of the past month, this exact volcano had been doing something far more modest. Through late July and August, Ambae was producing ash plumes in the 10,000 to 15,000 foot range. On the 30th of July, the Wellington Center logged a plume to roughly 3 kilometers, about 10,000 feet. On the 4th of August, about 4.5 kilometers, roughly 15,000 feet. On the 16th of August, back down to around 10,000 feet. Steady, persistent, a little grumpy, but routine for a volcano in an ongoing eruptive phase. The local geohazards department was reporting continuous tremor and a steady exhale of steam, gas, and ash from the summit. Nothing about that baseline said catastrophe. And then, in a single pulse, the column went from 15,000 feet to 54,000 feet. That is not a gradual climb. That is an order of magnitude jump in how high the volcano is throwing material. And because eruptive energy scales far faster than column height, the jump in raw power behind the eruption is larger still. In the space of days, Ambae crossed the line that separates ongoing background activity from a major explosive event. When a volcano makes that leap, it is telling you something has changed underneath it, and the question that immediately follows is whether the change is a one-time burst or the opening move of something bigger. Consider what it actually takes to loft ash that high. To reach the stratosphere, a volcano has to sustain a jet of gas and rock energetic enough to punch through the entire lower atmosphere and stay buoyant the whole way up. Weak eruptions cannot do it. Their plumes stall out at a few thousand meters, spread sideways, and drift away. To get to 16 kilometers, the eruption has to be driving material upward with tremendous and sustained force, and that force is a direct readout of how much gas is coming out of the magma and how fast. A taller column is not just a taller column. It is the visible signature of a more powerful eruption, and it is the reason experienced observers treat a jump like this as a warning rather than a curiosity. The height also changes who has to worry about the ash. At cruising altitude, volcanic ash is invisible to pilots and lethal to jet engines because the fine glassy particles melt inside the engines and can flame them out. A cloud topping 54,000 feet, drifting east and southeast the way this one was, becomes a hazard to every aircraft route in a wide swath of the Southwest Pacific, which is exactly why an aviation authority, and not a local emergency office, is the body issuing the formal measurements. And all of that follows from where this volcano is sitting, because the setting is what turns a dangerous eruption into something bigger. To understand why Ambae can escalate so violently and so fast, you have to look at what is happening at the summit. Ambae is a basaltic volcano, and its magma is what geologists call primitive alkali basalt, unusually rich in dissolved gas. That gas content is the accelerant. But the trigger for these explosions is water. At the summit of Ambae, inside the youngest caldera, sits a cluster of crater lakes, and the active one is called Lake Vui. When hot, gas-charged basaltic magma rises up into direct contact with the water in that lake, the water flashes to steam almost instantly. That flash is explosive. It shatters the magma into fine ash and blasts the whole mixture skyward. This is what volcanologists call a phreatomagmatic eruption, magma meeting water. And it is Ambae's signature move. It produces fine, far-traveling ash, acidic gases, acid rain that falls on everything downwind, and lahars, which are fast-moving volcanic mudflows that form when all that loose ash mixes with lake water and rainfall and comes rushing down the slopes. A 54,000-foot column at a lake-filled basaltic volcano like this one tells us the interaction just got far more violent, or that the eruption is shifting toward a more sustained, gas-driven style where the magma itself is doing more of the work. Either reading points the same direction, which is up. The consequences of that mechanism reach well beyond the summit. The acid rain generated by a phreatomagmatic eruption strips the leaves off crops and contaminates the rainwater catchments that island communities depend on for drinking water, which is one of the practical reasons an escalation here forces people off the land even when no lava is anywhere near their homes. The fine ash coats gardens, chokes water supplies, and settles into a heavy, wet blanket that can collapse roofs. And the lahars are their own distinct threat, because they do not need the eruption to keep going. A slope loaded with fresh ash, hit by the tropical rain that is routine in this part of the Pacific, can send a churning wall of mud and rock down a valley hours or days after the eruption itself has quieted. So the danger from a pulse like yesterday's does not end when the column stops climbing. It lingers in the ash left behind. The eruption is more energetic today than it was a week ago, and the mechanism that drives it is one that can turn on hard and fast. Now let me show you the thing that most coverage of this eruption is going to miss, because you cannot see it from a photograph. The Ambae you can look at, the green island with a smoking summit, is only the top of the mountain. Ambae is the single most voluminous volcano in the entire New Hebrides archipelago, an enormous basaltic shield estimated at roughly 2,500 cubic kilometers of material when you include everything below the waterline. The summit stands about 1,496 meters above the sea, but that visible peak is only the top 1,400-odd meters of a mountain whose real bulk sits down on the seafloor, hidden under the ocean. The top of that shield is capped by a complex of nested calderas, collapse craters sitting inside collapse craters. The outer structure runs about 12 kilometers across, with a roughly 6-kilometer caldera nested inside it. And within the youngest of those sits the pyroclastic cone that holds the 3 summit lakes, including Lake Vui. Those nested calderas are themselves scars from past collapses, evidence that this mountain has partially fallen in on itself before, which is the geological record telling you what this volcano is capable of when it is pushed hard enough. I'm walking you through this architecture for a reason, and the reason is that a large, mostly submarine volcano with a broad caldera is exactly the class of mountain where scientists have to keep one eye on the possibility of the flanks or the crater walls giving way. When a volcano is mostly underwater, its slopes are supported by the surrounding sea, and a violent eruption, a sudden withdrawal of magma, or a strong earthquake can destabilize those slopes in ways that are hard to see coming and hard to monitor from the surface. Nothing in the current data says that is happening at Ambae right now, and I want to be careful not to imply it is. But the shape of this volcano is part of why an eruption here draws a different kind of attention than an eruption at some tidy little cone on dry land. A big pile of rock, mostly submerged, sitting in deep water, is a structure whose failure modes involve the ocean, and that attention, yesterday, went international within hours. Before we get to the fault, you need to understand what an escalation at Ambae means for the people who live on it, because this is not hypothetical for them. They have had to run before. In 2017, during an earlier eruptive crisis, the authorities evacuated the entire island, roughly 11,000 people, moving them off Ambae until the volcano calmed enough for them to return that October. Then it happened again. In April of 2018, a state of emergency was declared. By late July, the government had ordered a full mandatory evacuation of the whole island, around 10,000 people, and in the first days of August, those evacuations began, carrying residents across the water to the neighboring islands of Maio, Pentecost, and Espiritu Santo. So when the ash column jumped to 54,000 feet yesterday, the stakes were not abstract. This is a community that has twice been forced to abandon its own island inside the last decade, And the question of whether they will have to do it a third time is sitting right there, unanswered, as the eruption intensifies. That question gets sharper when you look at the one official number that did not move. Here is one of the genuinely strange things about this event. Vanuatu rates its volcanoes on a scale that runs from 0 to 5. All year, through this ongoing eruption, Ambae's alert level has been held at 3, which on that scale denotes a minor to moderate state of eruption. A 3 is not an emergency. A 3 is a volcano that is active and being watched, and through all those weeks of 10 and 15,000 foot plumes, a 3 was a fair description. But a 54,000 foot stratospheric column is not a minor to moderate event. It is a much more energetic eruption than the alert state baseline implies. That is not necessarily a failure by anyone, because an alert level is meant to describe the hazard state on the ground, and column height is a separate quantity measured a different way. But it does raise a real and uncomfortable question, which is whether the official alert level and what the satellites are actually observing are about to diverge, and how quickly the people responsible will move if the eruption keeps climbing. When you see a volcano doing stratosphere-level things, while its official rating still says moderate, you watch for the gap between those two to close. And the reason that gap matters so much here comes down to the ground this volcano is standing on. This is the part the title was pointing at, and it is the reason this eruption is more than a spectacular ash cloud. Ambae does not sit in a quiet corner of the ocean. It sits inside the Vanuatu Island Arc, also called the New Hebrides Arc, and directly beneath that arc runs the Vanuatu Subduction Zone, one of the most dangerous fault systems on the entire planet. This is a convergent plate boundary, a place where one slab of the Earth's crust is being forced down beneath another. Here, the Australian plate is grinding down underneath the Pacific plate, and the standard scientific references describe this boundary as currently one of the most active subduction zones on Earth, a fault system rated as capable of producing great earthquakes of magnitude 8 or larger, with the potential to send tsunamis across the whole Pacific Ocean. And this boundary is moving fast. In places along this arc, the plates are converging at more than 100 millimeters per year. To put that in perspective, that is several times faster than the long-term slip rate of the San Andreas Fault in California. A fast-converging, highly active megathrust is a fault that is loading up strain quickly, and the faster a fault loads, the more often it has to let go in a large earthquake. This is the fault that lies directly under the volcano that just erupted into the stratosphere. That is the co-location at the heart of this story, and it is worth being precise about what it does and does not mean. The volcano and the fault are not two unrelated hazards that happen to share a neighborhood. They are both products of the same subducting slab. As the Australian plate dives down beneath the Pacific plate, it drags on the boundary above it, which is what loads the megathrust. And it also sweats water and melts into the mantle above it, which is what feeds the magma that builds volcanoes like Ambae. So the earthquakes and the eruptions in this arc are siblings, born from one process. That shared parentage is real science, and it is the honest core of why this eruption is unsettling. You have a stratosphere-reaching eruption sitting on top of a fault, flagged for a great tsunami-generating earthquake, in the same place, at the same time, driven by the same machine. And this region has been reminding everyone lately exactly what that fault can do. This is not a sleepy fault that scientists worry about in theory. It has been actively breaking. Back in March of this year, on the 29th, a magnitude 7.3 earthquake struck Penema province, causing injuries and extensive damage on Espiritu Santo, which is the very same northern Vanuatu region that contains Ambae. Go back a little further to December of 2024, and a magnitude 7.3 earthquake struck near Port Vila, the capital of Vanuatu, killing 14 people, injuring hundreds, and causing damage running into the hundreds of millions of dollars. And the deeper history is worse. Across this arc since 1900, there have been on the order of 2 magnitude 8+ earthquakes and dozens of magnitude 7 events, including the 1999 Pentecost earthquake of magnitude 7.5, which generated a local tsunami with wave run-up of several meters and killed people. So this is a coastline that keeps rupturing, driven by that fast-moving slab underneath. Notice the pattern in those dates: a damaging magnitude 7 earthquake near the capital in late 2024. Another magnitude 7 in the same northern province as Ambae in March of this year, a history stretching back over a century that includes great earthquakes and deadly tsunamis. This is not a fault that might someday become dangerous. It is a fault that is dangerous right now on a human timescale, and it has been actively demonstrating that fact in the months leading up to this eruption. And that same slab, that single subducting plate, is the engine behind both the earthquakes and the volcano. The magma that feeds Ambae and the strain that loads that megathrust are two faces of the same tectonic machine. which is exactly why yesterday's eruption raised a question that reached all the way to the other side of the ocean. Because once you have a violent eruption at a mostly submarine volcano sitting on a fault like this one, in a region with this seismic history, someone is going to ask about a wave. Within hours of the eruption, something happened that would have sounded absurd a few years ago. According to Chinese state broadcaster CGTN, citing Japanese media, authorities were investigating whether this eruption could send a tsunami all the way to Japan, thousands of kilometers to the north, a volcano in Vanuatu, and officials in Japan checking their coastlines. I want to be very clear and very careful here, because this is exactly the kind of claim that gets distorted. As of right now, that is an investigation, a precaution. It is not a confirmed tsunami. There's no basin-wide wave that has been verified as heading anywhere. But the fact that the question was asked at all is not paranoia, and to understand why, you have to remember January of 2022. That was when the Hunga volcano, sitting roughly 2,000 kilometers southeast of Vanuatu in this same broad stretch of the southwest Pacific, produced one of the most violent eruptions of the modern era. Its column reached the stratosphere and beyond, into the mesosphere. And it did two things at once. It generated a tsunami that crossed the Pacific, and it launched an atmospheric pressure wave, a pulse in the air itself, that circled the entire globe and drove strange sea level oscillations in places thousands of kilometers from the volcano. In Japan, an ocean away, tsunami-like waves of around 1 meter were observed. The Japan Meteorological Agency issued tsunami advisories and warnings, and evacuation advisories went out to large coastal populations. That single event rewrote the rulebook. Before it, the working assumption was simple. To threaten a distant coast, you needed a great earthquake, because earthquakes were the only thing that moved enough water. Hunga broke that assumption in a single afternoon by showing that a volcano could do it 2 different ways at once, through the water and through the air, and that the effects could show up on the far side of an ocean before anyone had fully understood what happened. It caught tide gauges and coastal communities off guard precisely because it did not fit the earthquake template that warning systems were built around. So when a big eruption happens in this region now, checking whether a wave could travel is no longer alarmism. It is the responsible thing to do, and it is a lesson written in very recent memory. It helps to understand how an eruption can create a tsunami in the first place, because the mechanism is completely different from an earthquake tsunami. And the difference is what makes these waves so treacherous. An earthquake tsunami comes from the sea floor suddenly lurching up or down and shoving the whole water column with it. A volcanic tsunami can come from several sources instead. A submarine or coastal explosive blast can directly displace a huge volume of water. A caldera or a flank of the volcano can collapse and dump an enormous mass of rock into the sea. Pyroclastic flows, avalanches of hot gas and debris, can pour into the water and push it. And then there is the atmospheric mechanism that Hunga demonstrated, where the pressure wave itself drives the ocean, a so-called meteotsunami. There is a further reason volcanic tsunamis are so dangerous, and it is about warning time. An earthquake tsunami announces itself with a large earthquake, and that seismic signal races through the planet at the speed of sound in rock, reaching warning centers minutes before the wave itself moves anywhere. A flank collapse or an underwater blast produces little or no clear earthquake signal, so the wave can be generated silently, from the warning system's point of view, and the first indication that anything is wrong can be the water pulling back from the shore. That inversion, where the eruption itself is the only warning you get, is what makes this category of hazard so hard to defend against, and it is why officials investigate the possibility early, rather than waiting for confirmation that may arrive too late to act on. Remember that Ambae is largely a submarine volcano with a broad caldera. That is precisely the class of volcano where water interaction and flank stability are things scientists have to think about, even when, as now, nothing in the current data indicates a collapse is underway. And the history books hold the warnings. Anak Krakatau, in December of 2018, suffered a flank collapse that generated a tsunami killing more than 400 people in the Sunda Strait, and it did so with essentially no earthquake warning. Because the seismic signal from a collapsing volcano is weak or absent. The wave simply arrived. And Krakatau itself, back in 1883, produced tsunamis that killed tens of thousands and registered on tide gauges around the world. These are the reference points that turn a question about Ambae from science fiction into a reasonable precaution. But a precaution is all it is, today, and the honest thing is to say so plainly. So where does this leave us this morning? The most defensible reading of the situation is this. Ambae has entered a markedly more energetic phase of an eruption that was already ongoing. throwing ash into the stratosphere and forcing the world to pay attention to a volcano that has already emptied its own island twice in recent years. It sits on top of one of the most dangerous megathrust faults on Earth, a fault that has been breaking repeatedly in this exact region. And the two hazards, the mountain and the fault, are being driven by the same subducting slab beneath them. That shared engine is real. What is not established, and what you should be skeptical of if you see it claimed, is that the eruption is about to trigger the Great Earthquake, or that the earthquake triggered the eruption. The stress an ash eruption puts on a megathrust is tiny next to the strain that fault accumulates over centuries of plate motion. They share a cause. One does not set off the other. There are three specific things to watch in the coming days. First, whether Vanuatu's Geohazards Department raises Ambae's alert level beyond 3 and orders another evacuation, and whether that 54,000-foot column sustains itself at stratospheric height or turns out to have been a single violent pulse. Second, whether the Japan Meteorological Agency and the Pacific Tsunami Warning Center confirm, downgrade, or quietly close their investigation into a wave reaching Japan. And third, whether the megathrust under Vanuatu produces any notable earthquakes in the days around this eruption, because that is what would tell us whether the co-location is anything more than a dangerous coincidence. Watch the alert level, watch the coastlines, and watch the column. Each of those three answers will arrive on its own schedule over the coming days, and together they will tell us whether yesterday was a single violent spasm or the start of something that forces this island to empty out for a third time. This is a volcano and a fault that both demand respect, and yesterday, for a few hours, they put on a display of exactly why. We will be tracking every one of those threads as this develops.